morning, ladies and gentlemen.
We're ready, guys.
My name is Shuqing Wang. Working together with Steven in the same office. This is my first time to attend this users group meeting, and I'm very happy to have this opportunity to see everybody here in person. And I will have 5 topics to cover today. And the first one is HPMS traffic data review tools. We recently developed a tool to help the reviewer to automate the traffic data review by compare 2 years of data. It provides an automated tool and also a series of quantitative reports. And the second one is,
would you mind?
Oh yes. The second one is about connected vehicle study. We recently studied 2 types of connected vehicle data type. The first one is curated from different motor manufacturers and collected, integrated by video company. And the second data type is received from roadside units. And that data set is a part of a joint program office connected vehicle pilot program. The third one I want to update is about travel demand modeling project. We just initiated a project by using the freight analysis framework version 5's network and the next generation national hospital travel survey programs OD data to develop the nationwide passenger flow map and the VMT composition reports. The number 4 is about national travel demand assessment. It's a forecast, the VMT forecasting. The last one I want to update is the traffic monitoring data accuracy specification method. Let's move to the next one. FHWA recently developed a tool allowing the HPMS data comparison through between 2 years submittals through using both summary quantitative reports and visual check at the segment levels. Enables both quantitative and visual understanding of the data change compared to the last years. By using these tools, the reviewer can view the change in the ArcGIS Pro. You can see the segment level change one by one, and also you will have a series of tabular reports so you can understand the quantitative change. The tool is focusing on 15 traffic-related data items from HPMS, and also shown in this screen. And it has 15 of them, and including whether or not a roadway segment is a sample panel or not. And the data check comparison is on ADT, ADT single unit, ADT combination, direction factor, key factor, and all the way up to the future ADT. Probably the first question as a reviewer of the traffic data, the question we ask is how much of the data of a particular data item is missing and where the data item is missing. So the tools provide a Python package allowing the user to using the ArcGIS Pro to automatically pull a data item. We have several different items. You pick which data item you want to check, and it will automatically show you 2 layers of them. The first one is about where your data item is missing. They show them by different color according to different function class, as shown in this one. So on the left side, you would see different symbology by different function classes, and on the right side, it's just a GIS map. And this the second layer it includes is in addition to where the data is missing, the second layer is how much the data is changed. And this map just shows where the missing. The next one you're seeing here is just how much the data is changed. For different states, the situation may be different, so the tools allow you to specify a different threshold. For example, -10%, -5%, +5%, and +10%. That to create 5 different acceptance criteria, meaning if the change is over -10% or over +10%, it will display as red, indicating those kind of segments is not acceptable. And if the change is within -5% to +5%, it will be displayed as a green color and indicating it's okay, it's acceptable. The good thing of this tool is those threshold values can be changed according to different states. For example, Virginia may use this set of threshold, and the other state may using different. In addition to each those traffic data item on the map, and the tools always also provided 2 types of cross data items check validations. For example, we provided 2 criteria. The first one is the derived ADT single unit value from the ADT and the design percentage design hour single unit, and the actual submitted ADT single unit has to be within a certain range. The second criteria is the total of ADT single unit and the combination has to be less than 80% of them. And by using these tools, you can pick which criteria you want to check. For example, like this one, they just pick the first one, so it shows the colors, different colors on the map, like this one. And on the left side, you would see we have three different types of colors. If it is marked as a red color, which means okay, for that particular road segment, that criteria is filled. Green means it's passed. And there's a third color, which is gray, which means any date of those involved date items missing, then that criteria check is filled. We mark it as a gray. For example, when we check the first one, you have to be to have 3 data items: ADT single unit, ADT, and the design hour percentage. If any one of those 3 data items is missing, it will be marked as a gray here. Maps shows above just provided the visual check at the road segment level, and as I mentioned earlier, it also provides a series of reports. Now let's just introduce those quantitative reports. The tools provide 12 different quantitative analysis reports, as shown on top of the screen. You see 1, 2, up to 12. These tools, the first one is to provide an overview as the first reports about the data missing. So horizontally, you would see, let me zoom in here. Horizontally, you would see there are several different groups, and each group lists 2 of them. One is missing, another one is submitted, and the vertical, it shows the total mileage. And on the right one, just shows the percentage, like this one. And the horizontally is grouped by different function class. The good thing of these reports is they provide a lot of different options. For example, you can pick which data item you want to check. Like this one, it shows ADT, and also you can select what's the scope. You can select I want to only check the sample panel data items, or you just want to check the universe, and you can drop down from this one. And also, it provides a special terminology in this data comparison. It is invalid change. For example, when we comparing the data from previous years and this year's, if data of any year or both of them are missing, the comparison will be failed. If a segment failed comparison, we mark as an invalid change. So this option on the reports just give us an opportunity whether or not to include the invalid segments into your summary report. And apparently, we use very often is about which area you want to check. Is you want to check the rural area or the urban area, so you have this drop down. And that is the first report, which is very important for the review. They give us whole pictures of how many data is missing, how many is submitted. After review of the data missing in the first chart that gives the whole pictures, and this chart just gives us an opportunity to understand the total mileage at each individual change percentage. It's a list from left side. Let me zoom in. Each horizontal point on the x is a particular change percentage. Horizontally, they list the lowest on the left side and the highest on the right side. The vertical is just the total mileage on the left side, and on the right side is the cumulative mileage. And again, it provides different options to allow you to select. One particular option is about the threshold to differentiate the different criteria. For example, you can select the -20 as minus 20% as the acceptable range, or manage a positive 10, 15, or something like. You can change those values from those drop-down list. And also, you can select a different function system and pick a different data item. And as mentioned earlier, you can also pick whether or not you want to include invalid change. This chart gives just very detailed information about how many mileage for a particular chain. And the blue line is also very useful. It's the accumulated total mileage. So whenever you see a jump of the blue line, like in this area, in this point, which means at that particular change percentage, there's a big contribution, big spike, as we are seeing the yellow one here. A good feature of this report is whenever the user changes the different threshold, you would see the bar, the vertical bar, the color of them would be changed. For example, the red colors are shown on the left side is unacceptable, the yellow is cautious, and the green shows here. If you change the threshold, you would see the color just shift left or right. That is the mileage for each change percentage.
So
now,
can you go back to that? Can you zoom in on the left-hand side there? At the very bottom, -60. So you're saying you had a couple of roadway segments that between years, it showed a 60% decline on some segments. Is that correct?
60%. No.
-60.
Yes, but that is very little.
But there are a couple segments.
Yes. But that is very little, so you need to pay more attention if it is the percentage change is very big. At the same time, like this one, is very high. Then you need to pay more attention. Why you have so many mileage for that particular change? Total mileage change at each change percentage. Total mileage at each change percentage just give the detailed information about the daily change. Now this report just use another way. They grouped the change range into grades, and like the horizontally, we just see them grouped by different acceptance criteria. Basically, we just group a certain range of the change percentage into one group called unacceptable decrease, unacceptable increase, or just acceptable or be cautious. And this picture just give us the a general idea about how good your data quality is compared with the previous years. And there's one thing I want to mention here is there's one bar listed on the right is invalid change. As I mentioned earlier, when we compare 2 years data, if the data of either year is missing, that comparison will be failed. We marked as that segment as invalid. These reports also tell you how much the totality is that kind of category.
But if they move their samples, it would be missing, right?
Yes, so we give you different options, allow you here to select the scope. If you don't want to see the picture of the universe, you can drop down them to select the samples. When you change the samples, then the vertical bars will be changed accordingly. Next one is, as we mentioned earlier, in addition to check on each data items from AADT to future AADT, it also provides two cross-check validations. The one is about the AADT single unit and the design hour, percentage design hour single unit. That three values has to be meet some criteria. The second one is the total of the single unit and the combination has to be less than 80% of ADT. And I remember HPM's version 8 has some other kind of traffic-related cross-check validations. And later, if we think that is necessary, we will expand the tool to add some new cross-check validation. But as of right now, we just implement two of them. And accordingly, in this report, you would have options. For example, you can, like this one, you can pick a criteria. And this report currently showing on the screen is just the first criteria. It's horizontally, it gives you two groups. The rural areas on the left side and the urban areas on the right side. And for each group, they further grouped by different function class. And let's zoom in here, so you can understand here. The left side is interstate all the way to the locals. And each bar will show three different colors from green, red, and brown. Green always means it's okay, it's passed. Red means failed, and the brown color means the failed to check that criteria because some data item is missing for that one. That's all I have for the first update. The second update is about a recent study on connected vehicle data. We studied two types of city data. The first one is curated from different motor manufacturers. They collected from their vehicles and integrated and by video companies. And FHWA was granted the access to a sample data size of this type of CV data for 1 day of Florida, the entire Florida state. And the second type is received by roadside unit. For example, if a connected vehicle, the status change, for example, the acceleration rate change, or something happens, and it will broadcast that message as a basic safety message to the surroundings. So the other connected vehicles can know the safety-related situation. At the same time, and if you install some special receiving unit on the roadside, you can receive those data. Those communication method is by using dedicated short-range communications. And this type of data comes from Joint Program Office Connected Vehicle Pilot Program. It currently includes 3 locations. The first one is Tampa's Hillsborough Expressway. The second location is in Wyoming Interstate 80, and the third one is the New York City. The study on this type, the second type of city data is still ongoing. Unlike any other type of traffic data, CV data is highly unique. With huge data size, huge data size, it's very easily to contain 1 billion records for one day, just such a kind of a huge amount. And the data items tied together, and it's very complicated. To process them, we really need some high power computing resource, and it needs a cloud-based data platform such as Databricks to handle it. And CV data provides more insight of the traffic. For example, it can tell us the travel or traffic behaviors, and it allows us to pinpoint potential spots over a map about kind of any safety issues related to the curvature of your geometry, marking, signing, and the weather conditions, and something like that. And it can also help us to understand some questions from travel demand modeling part. For example, giving one particular origin destination pair, from the CV data we can understand how a driver to choose their route. That is a very good help. Oops. Each CV connected vehicle car is a moving sensor on the road, and it is indeed a new way for us to monitor the traffic and do the survey. So we encourage state agencies to get engaged in collecting and processing the CV data, and we know it needs some technical skill to handle this one. Technically, we are standing by for any help. And if you need any help in this area, just feel free to contact with us. And since we have a lot of results that come from this study, but in this meeting, we just take a few minutes to illustrate a few of them so we can understand what we can do from the connected vehicles. Each records of a connected vehicle would provide at a minimum the geolocations and associated with each record. So we can easily plot those events on a map to understand what's their relationship to different geographical locations. For example, for the Florida state, we divided the entire state by many square areas. Each square area is 2 kilometers by 2 kilometers. We simply aggregate all the events, for example, the hard brake event or hard acceleration event within each area, grouped by different R. And we plot those areas by a dot on the map. Each dot you are seeing on this map represents each of those rectangle areas. The side of the dot represents how many events happened within that particular area at that R. And the color represents the average speed of when that event happens. So, so we can understand something geographically, and this, as shown on the bottom, from 0 to 23, that's the hour of the day. In the real time, we can play them. When we play them, you would see the dot just change from this one to other one according to the hour of the day. There would be many different types of events rather than in addition to the hard brakes. For example, whenever you accelerate too much, they will send the information about hard acceleration. Whenever you click latch your seatbelt, that event will be sent out as well. And also, you turn on the wiper, you turn on the latch. Those kind of events are included. And the same thing as the hard brake. So similarly, we can plot, for example, the number of seatbelt latched events on this map. It is the same thing, but the event type are changed. and at the same time you can play them from hour to hour. And when you play them, you would see at what particular time the latched and unlatched event has more. The number of seatbelt latched and unlatched may not be a good measurement of the usage of the seatbelt, because the latched unlatched event is durational. You have more activities on latched and unlatched does not necessarily means you use the seatbelt more, right? You keep latched and unlatched does not mean you use more the seatbelt. So accordingly, we just developed another report, and as shown here, it tells us how many travel time the seatbelt is latched versus unlatched, as shown here. Let me zoom in. You would see the horizontal is grouped by different travel distance. The vertical, you would see two bars. One bar, the blue bar, is the driver's side seatbelt latched, and the yellow one is unlatched. And on the left side, you would see the travel time. And from this chart, we can understand that from the long travel distance, and has the driver using the seatbelt more than short distance, and even it goes reverse. For example, from short distance, from 0 to 10 kilometers travel, and we found that the unlatched percentage is higher than the latched. That's the driver side. Similarly, we can do the graphics for the passenger side, and this one just shows another chart, but it's for the passenger side seatbelt usage. And apparently, compared with the previous one, we can understand that it seems that the passenger using the seatbelt more than the drivers. In addition to the driving event, the CV data provides another important data. Is they send the vehicle's location in an interval of every 6 seconds. So the data set is huge. So accordingly, we can simply connect all those points of one vehicle together to form a journey path, as shown in this. And let me zoom in so you can understand. Each line shown here is one car's travel path, and from location A to location B. You're seeing one line here, for example. Sorry. For example, you are seeing one line here. It does not mean it's one journey. It may have many journeys just overlap together. So having this journey path map, we can easily calculate it with other existing GIS features. For example, the Arnold geometries or the NPM RDS TMC segment. Once you calculate it together with them, we can easily understand what's the volume at any particular hour, at any particular road segment. And also, as I mentioned earlier, this map will help us to understand how a driver is to choose their route from giving one OD data pairs, for example, from point A to point B, why this user choose this route and the other user choose another one, something like the TDM questions. The above slide just shows a few results we obtained from the CV data collected by different manufacturers. Now, just let's introduce the second CV data type, that is broadcast by connected vehicle and received from the roadside unit. That's a totally different data type. This sample data set is from Joint Program Office CVP programs. And the one as shown here is Tampa, Florida. One type of a safety data, connected vehicle broadcast out, we call them a basic safety message. Whenever the speed of the vehicle is changed, either accelerate or deaccelerate, or if you change the lane, that causes the lateral acceleration change. And it will broadcast that kind of information as a BSM to the surroundings, so the other car can know the safety situations. And at a minimum, each data point, including the time when it happens and where it is and the speed, and also the actual value of the acceleration. For example, how much is the longitudinal acceleration, how much is the lateral acceleration. It also included the rate of the car doing this kind of turn. It tells you how much rate of the rotation. And by conflating those events dots with some existing GS features, for example, the NPM RDS TMC segment, we can easily aggregate those events together with the geometry roadway segment as shown here. Like this one, it shows the density of hard brake events at this particular road segment at each arc. And also, this map is shown in the ArcGIS Pro, and you can play it. Let me try. Yes. So when you play it, you would see the density of the event just keep changing. Sometimes you don't have it because you don't have that data at that particular hour, and sometimes you see red color, sometimes you see the green color. That helps us understand at a particular hour how much event happens in that particular road segment. Okay, next one. This map similarly just shows the density of another type of acceleration. As we mentioned, in addition to longitudinal acceleration, it also has a lateral acceleration. It shows that type of event, and so we can understand the traffic varying when the driver changes lanes from one to another. That would cause the lateral acceleration, or it helps us to understand the effects on driving on curved roadways. When you're driving in high speed on curved roadways, that causes the lateral accelerations. This map just shows another example. It's Wyoming's Interstate 80. They just simply plot all the events, longitudinal events in one map, so we can understand them. Also, this map can be played hour by hour. And in addition to using a GS map to show the acceleration events, so we can understand the the safety issues related to geographic locations. We can also do some quantitative analysis, and we provide different graphics reports like this one. This one shows the total number of acceleration channel points by degree of curvature and HOD, hour of the day. One thing we need to know that is the CV data itself does not have anything about your roadway segment. It simply tells a point here and what's the speed, what's the accelerations. In order to derive this kind of analysis result, first we need to calculate those CV data together with your roadway segment. For example, we're just using the NPM RDS TMC segment, conflict them, and calculate the degree of curvature of the road, and group them by different degree of curvature. Let me zoom in so you can understand. Okay, you see this line just shows the degree of curvature. They're using a different color of them to differentiate. Each degree of curvature using a line, grouped by a line. And also, it gives you some other options like shown here. Is like it's shown here. You can pick the acceleration type, either longitudinal or lateral, and you also can have a selection for different range of them. For example, if you want to see hard brake or soft brake, you can have that option. So they will group show on this reports as well. And on the left side, the vertical part is the total number of those events. Similarly, we can show the average speed group by different degree of curvatures and the hours of the day. Let me zoom in so we can understand the options we could have. And for example, you can pick a roadside unit. I want to see Florida's this particular location rather than Wyoming's. You have that option to select them. And also, I want to pick this data and not others data. And then you have that options. And also the line, the is grouped by different degree of curvature. And the left side is the average speed. And in the next one, you would see a little bit different. This one just shows the maximum speed, grouped by the same thing, degree of curvature and an hour of the day. And the option on the right side is the same. Next one is we shows the total number of acceleration change points by range and hour of the day. The options are a little bit different, and some are same. You can pick a date, a roadside unit, and also you can pick a range, whether or not it's a hard brake or soft lateral acceleration, something like that. And in the next chart, it just shows the little bit complicated information. It shows the total number of acceleration change point together with the average speed and the maximum speed. And the vertical bar rendered in different color. The color represents the maximum speed. For example, the red color, which means the highest maximum speed, and the vertical bar, the vertical axis is the total number of such event you selected, and the line, the blue line shows here, that's the average speed, and the options, it has quite some of the options. For example, you can pick the range. For example, I like to show all the range, hard brake, hard acceleration, soft acceleration, and something like that. And you can pick which degree of curvature of the road you want to show. It give you a list to select them. And also you have the option to select it is on the NHS or not. The reason we provided this option is because not all the city data has a roadside calculated. Because currently we're just using the NHS to calculate this data. The NHS segment does not cover everything. So that is the reason we give you the option. You can select on NHS or just all of them. And this is all I have for the second city data study result. And one thing we want to know, to let you know that is this study is not finished yet and it's still ongoing. And our next goal is to conflate the basic safety message together with another set of message. We call them traveler information message. When you drive a connected vehicle car on the roadway, whenever the car see a road signs on the left side or right side, it will send the message, broadcast the message to the surrounding cars. That message we call them traveler information message. We are trying to conflate those messages together with the basic safety message and the existing GS features. So we would know where on the road has signs. We particularly focus on the speed limit signs. And then once we know for this particular road segment the speed limits, and also we have the VSM message there, so we can understand how a car is traveling, how fast a car is traveling against the speed limits. That's all I have on this one. Here I want to provide a brief conclusion on the CV data. I would like to emphasize that CV data is highly unique and complicated. it can reveal a lot of traffic-related behaviors. It's truly a new way to do the traffic monitoring. So we encourage the state agencies to get engaged in these areas. And technically, as I mentioned earlier, we're standing by here. If you need any kind of help, we're ready to help you. Just feel free to contact with us. The next update is about travel analysis framework. FHWA just initiated a project to establish the nationwide passenger flow analysis framework. It is based on the Freight Analysis Framework version 5's network, and will using the next-gen NHTI's OD data to produce the nationwide passenger flow map. The objective of this project is produce the nationwide flow map, and also produce the VMT composition reports for each state and the top 50 MSAs on their interstate and the entire national highway systems. The next update is about National Travel Demand Assessment, VMT forecasting. The Balaki National Transportation System Center just developed some travel forecast model for federal highway. Those models enable the forecast in changes in the use of vehicle VMT that are likely to occur in response to the predicted change of the future economic and demographic change. It uses widely adopted statistic and economic techniques and to estimate the influence of the underlying economic and demographic factors, those influence on the vehicle use. The project manager of this project is Clinton Clark, and please feel free to contact with him if you have any question about this one, or if you want to know detailed information about this project. On the top of the title is a link, the National Travel Demand Assessment VMT forecasting. They already have the link there, and later we will send the PowerPoint to Laura, so you can this PPT, you can visit there. The last update is about the traffic monitoring device accuracy specification method. Federal Highway is planning to carry out this project to develop a method for traffic monitoring device accuracy specifications. Since new monitoring technology just come out day after day, and it becomes more urgent that we have a standard and practical procedures to benchmark the accuracy of their device. And the current TMG is very extensive, but that is not covered about how to specify the accuracy. And it will cover different level of service. For example, it will cover the stop and go and peak hours and free flow state, and under different conditions. For example, different lighting, different weather conditions, and even different pavement conditions. And this guide will establish the reference traffic count as a reference to allow the vendors or the other users to bench up their accuracy of a particular device. And also, this project will establish a technical panel from different state agency, MPOs, and vendors, and university research to make sure the guide is practical and meaningful. And that's all I have. And thank you very much for your time. If you have any questions, just feel free to ask. Thank you.